Good morning, everyone. My name is Dr. Raja from Tirutanga Nara College. I am today teach about nano material. So nano material means small tiny particle, the range of 0 to 100 nanometer. That today I see about the introduction of nano material. So firstly introduce the Richard Feynman. Will introduce the small particle, also well as called the tiny particle, in the range of 0 to 100 nanomaterial particle. This material will be made up of the range of material will be converted or synthesis of some natural product or unnatural of the product. So history of the nanoparticle is a nanoparticle is capable of the sizes of the material. So is a classification of the three types of the material. So one is a 0 dimensional, second one is a 2 dimensional, third one is a 2 dimensional. So 2 dimensional. The material is also called the 0 dimensional material is also called the small range of material. Small range of means at a level of 0 to 10 nanometer range of material. Again is a 1 dimensional nanomaterial also called the 1 to 20 nano range of the material. Also third one is the 2 dimensional material. The 2 dimensional material is also called the is a nanotube or a nanorod or nanoflux. This material is also called the 2 dimensional nanomaterial. The material also synthesis. The material also, what is the nano material? So nano material means in the range of 0 to 100 nanomaterial. If you matter of some tiny particle or some rise of or wide range of material will be packing in the nano material. That material will be synthesized through the different type of the method. One is a top down and the bottom up. The method of follow the material is a top down approach to the small particle, bottom down approach to the small particle. The material also called that. The particle will be a range means is a bulk material will be converted to nano material. That type of material also range of 10 centimeter will be converted to 1 millimeter and 1 micrometer. 1 micrometer another than the 1 nanometer. So it will be smaller than yard. So 100 times of small will be classification of the small or vessel nanomaterial in terms of nanometer range and micrometer range of the material will be present in that. There will be specifically the presence of the specific material. There are the types of the nano section. Will be the material also the type will be 2 dimensional nanomaterial is a size types of the nanomaterial. One is a cluster. The cluster is atom will be converted to cluster range, and again is a nanotubes and fiber and rods is a form of 1 dimensional nano section. Second one is a 2 dimensional is a flame or coating. The flame means also in a thin film. Coated means added to the many more material into coated to the another layer of the part is a 2 dimensional. So last one is a polycrystal. The polycrystal means the arrangement of atom will be number of layers. A number of crystal will be present in a polycrystal is a 3 dimensional. The method with the synthesis method also approach to the 2 type of the method. One is a bottom down approach. Second one is a top down approach. Okay. Top down approach means will be bulk material will be converted to small range of nanomaterial. Second one is a bottom up approach will be convert to the atom will be converted to nanomaterial region. Then there is a method will follow the 1 to 3 material. So the top down approach generally will be follow the top down approach is a bulk material. So there is a method of follow the ball milling. So ball milling is like a very huge particle will be converted to small range of nanoparticle is a form of nanoparticle. That is the top down approach will be the image will be focus of the approach or a same will be take about the image will be presence of the small size of the surface images. Next one is a bottom up approach. Bottom up approach will be form of the atoms. Atom will be converted to nanomaterial. Nanomaterials are the molecular precursor. The structural unit will be converted to the nanomaterial. So the method follow the commonly used method will include the solder. So solvent means like a liquid will be atom will be dissolved with the liquid. Again the cluster forming. Again the dry next process will be dry formation. Next to the nanomaterial will be formed. That is a form of isothermal and physical and chemical vapor diffusion and the external physics. The method will be shortlisted through the synthesis of nanoparticle. First one is a top down, second one is a bottom up. So bulk material will be converted to powder, will be form of nanomaterial. Next, the atoms will be converted cluster, will be converted to nanomaterial. That is a form of different method will be synthesis of the nanomaterial. Clear? Nanomaterial. The material also depend upon the sizes. The material will be different upon the sizes, will be form of the different upon the application in the industry. Suppose nanomaterial in a nature. So nanomaterial in nature is the nature of light. We say for example the butterfly. Butterfly we take about the image in a and the different colors we reflection through the image of the pattern. Different color will image of the pattern. This is a form of the one layer presence of the is in a butterfly. So another is a presence of the colors. Depend upon the colors, the layer. The layer means it will be called as a or it will be recollect through the 0 dimensional or 1 dimensional or 2 dimensional range of the thin film or in a thin film or in a coating of the material. So the material of the colors will be reflect through the colors. So first one is here the spectrum will be form of the different range of the filter. Will be presence of the colors will be different upon the coating or coating means the form of the thin film. Thin film will be reflect through the light. It will be focusing on the surface of the image per crystal, per sample. Will be collecting the sizes of per nanometer of the ranges. So apply to the normal range of the material. Again apply to the transmission rate. Again to the normal one. Depend upon the range of the angle will be deviate to or reflect to the frame of the reference. Clear? The main butterfly of the colors. Colors means like particularly the surface image is focusing through the sun. Sun means the scanning electron microscope will be presence of the colors in through the range of nanomaterial in terms of micrometers. So next the cardinal line of the nanoparticle depend upon the colors with the presence of the ranges of sizes. Ranges of sizes means 0 dimensional, 2 dimensional, 1 dimensional of the pairs. Next, the undefectable properties of Kerke wings. So Kerke wings means so the wings is focusing the reflecting of the scale of images. The presence of the nanotips or nanodraws will be presence of the zigzag. Presence of the zigzag in a pattern of will be presence of the image. Next, mimicking of the undefectable properties of the character, it will be focusing the morphology through the surface area. Will be presence of the colors. Will be presence of the ultrasound sample and the nano raw treated of the sample. So image will be presence of the ultrasound. The next is the lotus leaf and self cleaning of the effect. The lotus leaf will be focusing or analyzing the different layer in the flowers, different layers in the flowers, analyzing the lotus leaf. Next in the Chicago fields, will be different color, will be focusing through the normal topology from the SEM and TAM. The nanomaterial arts in the culture of the heritage is a Feynman, already told of the Feynman, will be presence of the colors, will be small range of material, will be reflect through the total colors will be presence of the darkness and the imaginess. Next, the application of nanomaterial. Actually, the synthesis of the nanoparticle or nanomaterial will be depend upon the method of will be synthesis. Again, you take about the some characterization. Characterization means you take about the some electron scanning electron microscope and transmission electron microscope. You take about the some images. Depend upon the surface of the atom or bonding of the energy level through the surface level and reflect through the light range or reflect on the thin layer of the material. Will be discussing about will be collecting through the application of the nano material. So first of all, I say take about the paints. The paints means the incorporating nanoparticle paints could be improve the performance. Already you know the paints. layer will be added to the paints. Original layer will be reflected through the sun rays. That is form of the paints. Okay, it will clear up the. It will be applied to the some light ray. It will be clear. Particular ranges will be presence of the brightly. That form of the paint. Second one is here the sunscreen and here cosmetics. Already see some examples for animals, butterfly and some peacock will be depend upon the light ray will be utilized through the UV or IR or NMR will be utilized through the ultraviolet. The traditional scaling UV production of the approaches the pre-launch tensibility. So actually the image will be presence of the more than layer will be reflect through the nano range of the or nano material of the particle. So efficient treatment. So nano material also called as here the application of some medicinally or treated to the human or animal through the parts. So the fields of the medicine. The nanotechnology is the metaphor here using a medicinal is a drug delivery from identify through the protein will be take out the cure of the some drug will be inside to the drug in here some part will clear up the medicinally of the object. So the overall drug consumption of the side effect can be lower significantly on the decomposition of the agent. The reason will be form of the depend upon the nanomateriality ranges. So next one is the sensor fragrance. Sensor is a wide range of material also. The nano material will be metaphor uses through the application in a sensors. Sensors also biosensor or will be reflected through the more than of the sensor. So our biosensor means is reflecting through the plant growing or plant drying, different method also using. The parameters are included in the resistivity, the chemical activity, magnetic property or thermal conductivity of the capacitor. So the sensor will be depend upon the magnetic property, include through the dia or ferromagnetic material will be sensorable for the all the material, all the sensorable produce the all the material. The carbon monoxide sensor, the zirconium oxide, it's a chemical stability of the direct of the presence of the carbon monoxide. Okay. So next in the NO2 or NS3 can be directed to the basis of the increase in the electrical conductivity of the nanoparticle. Will be range of or will be added to the some chemical or added to the some solvent. Will be impurity will be more than will be detecting the impurities. If we follow the NO2 and the NS3, the detecting the basis of the electrical conductivity of the material. So next one is a food. The nanotechnology can be applied in the production, processing in the safe and the packaging of the food. So nano material is a food faculty is a production. Production means so number of food product will be safely. Will be stored in the food. Will be used in the nano material will be used as the nano composites coating the process. Means nano composites means coating in another material. Will be crossing through the will be used through the long life. Is a form of the coating of the process. Cloud improve the packaging of the placing antimicrobial agent directly to the surface of the coated film. That antimicrobial agent. Antimicrobial agent means placed in the coating of the nanoparticle will be long life used through the particle of the coated film. The next one is a construction. The nanotechnology potential to make construction of the cost and safer of the world. So actually nanomaterial will be converted to the nanotechnology depend upon the developed in a countries. So nanotechnology will be used in a different of application in a electronics or industry, many more in a application through the part of usage. So the silicon, the presence of the conventional concrete part of the normal mix, the nano silicon added to the concentrate of the packing of the improve the mechanical properties. The nano size steel products the strongest steel cable will be follow the material. If we follow the material in through the electronics, the chip-based components or a semiconductor laboratory through the titanium oxide and the glycine. The application of nanomaterial is energy. So energy is here part of the is a nanomaterial. Nanomaterial is a small tiny particle will be utilized in the energy level. Will be utilized in the energy level at a solar panel, solar device, or some other part of using a energy level. The nanomaterials have the capacity of storing a huge amount of energy. The capacity will be stored in the huge energy of amount in a energy. The huge amount of energy will be stored in a capacity. The semiconductor material, the semiconductor device will be stored in a huge material in a device. Today the cells multiple layer of different semiconductor of the nanoparticle units. The semiconductor layer will be coating of the thin film. Coating of the thin film will be used in the large amount of energy in a device. There are the much more the efficiency than the one of the 20 years. There are presence of the year. The semiconductor will be used in a Chandrayaan 3 will be over Chandrayaan 3. The Chandrayaan 3 will be coated of the material. The program configuration through the CMOS, the camera configuration through the Chandrayaan 3. Next was a better insulation of the material, nanocrystalline material. Actually, is a nanocrystal or nanocrystalline material. That material also called the polycrystal. Polycrystal, many more crystal will be combined to the is a nanocrystalline material. So the synthesis the salt gel techniques result in a form of like structural called the aerogels. So aerogel means with presence of the solid, added to the some solvent is a colloid with the mingle of the aerosol. The presence of the yarn with the solid. The combination is a aerosol. This aerosol is previously extremely lightweight. The aerosol composed of the three-dimensional continuous network particle with the droplet and the industries. The torsion order of the cutting tools. Means the heavy huge material will be made of in a cutting. So very depend upon the strength or ductility. Very depend upon the strength and the ductility will be easily breakable or very strong material. If we will cut them through the nano material, that's a form of the hardened cutting tools using in a nano material. The cutting tools made up of nanocrystalline material such as tungsten carbide and the tantalum carbide and the titanium carbide much as harder, much as resistance and erosion of the resistance. So you will be remove the resistance and resistance of the emulsion will be reduced of the nano material. The tools are required form for a microelectronics. Very easily it will be passing through also light ray will be cut to the strong material to light material. So high power magnets. So in the material also the nano material used in high power magnets. High power magnet means is a ferromagnetic material will be form of the will be synthesis of the material is a ferromagnetic material. It will be used in a high power magnet in a many more application. The magnetic power depends on the specific surface of the area. For specific surface means you will collecting the some stem image. The surface ring will be automatically binding in the range of material. That is a form of the magnetic power depends upon the specific surface area. The magnetism of the nanocrystalline gain first the unusual magnetic properties due to the surface area. So it will be binded through the surface area or less or more. Will be using or utilizing the magnetic property will be higher power in a magnets. Higher power means the motors of the ship. Is a collecting a magnet or a domain bar or ferromagnetic material will be all the gathering through the magnetic performance. The inverse performance of the compounds. Let's the part of the more than utilizing a nano material in a industrial or electronics. The part of utilizing through the electronics depend upon the range of material through the materials. The increase the average of 200 to 300 range of material. The next one, the part of the wide range of material will be spread through the depend upon the demanded through the application in a market. So market needed or new change in the material process or new adapted to the property. So depend upon the material or nano material will be synthesis of the nano material, will be classification of the three-dimensional, will be convert to nanotechnology, will be depend upon the application through the different marketing and range of the material. This the conclusion our topic of nano science or a nano science with the nano material. The easily synthesis of the nano material depend upon the synthesis method for a top down and a bottom up approach. We will be collecting the sample, making the characterization depend upon the characterization for SEM, TEM or XRD or UV or FT, NMR. It depend upon the bonding of the energy level through the surface area. We will be monitoring, we will be collecting the application of different field in a nanomaterial. That's all. Thank you.